Good day, student. Nice to meet all of you back. This is our last lesson for this topic, chapter 11, Air and Water. This video is prepared for IGCSE Coordinated Science 0654. I'm Einstein Pillai Sankaran. Okay, this is chapter 11, Air and Water. It's the last lesson, lesson number 6. So all my previous lesson is in YouTube. I hope you can spend some time to go and find my previous lesson, lesson 1, lesson 2, lesson 3, lesson 4, and lesson 5 in the YouTube and watch before so that you can follow with this today's lesson as it is a sequence. Okay. So in today's lesson, it's lesson 6, basically the last lesson for chapter 11, Air and Water. So our focus is about importance of nitrogen, phosphorus, and potassium containing fertilizers. Number 2, displacement of ammonia from its salt. And number 3, Haber processed. So this is 3 focus today. My top 3 question: what are the important minerals for the growth of the plants? What is ammonia? The last one, how ammonia is produced. So if you know answers for all these questions, then you're on the right track. If you are not sure, you are also on the right track because we are going to learn about this today. Now, so take your pencil, write down the answer for these 3 questions in a paper, and as we go through, check whether your answer tally with our syllabus. So, all of you have seen fertilizers, okay? And the most common fertilizer is NPK. It's an example of fertilizer. So, N stands for nitrogen, P for phosphorus, K is for potassium. Nitrogen is required for the plant to produce green leaf. Okay, so by adding nitrogen mineral, the plant can produce many green leaf, and it is important for the growth as green leaf is important for the photosynthesis process. Now for the phosphorus, it is important for the root and blooming of the flower. So it is also added in the fertilizer. And the last, potassium, it is overall plant health. So generally, all the fertilizers usually have nitrogen, phosphorus, and potassium as well, other component. Okay, but these 3 element is the critical for the growth of the plant. Now, next, ammonia displacement. So what is ammonia? Okay, so some of you know NH3 is ammonia. Okay, ammonia exists as a gas or usually dissolved inside water to form ammonia hydroxide, okay, or known as very simple ammonium hydroxide, NH4OH, okay, usually dissolved inside water because plant only can absorb mineral in the form of ion that are dissolved inside water. They can't absorb gas as a mineral. They only absorb carbon dioxide for the respiration process. Now, so ammonia can be produced by a displacement reaction involving ammonium salt. So when you talk about ammonium salt, it means any compound that contains ammonia. Okay, so it's known as ammonium salt. So in this example here, when ammonium salt is react with a strong base, example sodium hydroxide, ammonia will be produced with water and salt. So this is just an example. You don't need to memorize this equation, just that you know that ammonium salt, when they react with alkali, they produce ammonia. Okay, this is one of the methods to identify ammonium salt also. Okay, so you don't need to memorize this equation. Just put this equation so that you can have an idea what is happening. So this happen usually in the laboratory. Now, so now we know what is ammonia. Ammonia is NH3, is one of the important component of fertilizer, because we know that all the fertilizer need to have nitrogen, phosphorus, and potassium. So nitrogen is coming from the ammonia. So the next question, how ammonia can be produced? So ammonia can be produced through a process called Haber. It's the name of a person by the name of Fritz Haber. It's a German. So this person developed and made many changes for this process. And he have found out that by having nitrogen and hydrogen, we can produce ammonia. And the nitrogen are usually obtained from the air. So you can watch back the lesson 1 for chapter 11, and you can see I've given you an explanation how nitrogen is formed by the fractional distillation of air. Okay, so they get nitrogen from there. Now, on the other hand, hydrogen can be obtained from the natural gas, cracking of natural gas, okay, or hydrocarbon, or even by steam processed. So they can get hydrogen. So once we have this nitrogen and hydrogen, they are passed over a catalyst of iron at a high temperature, about 450 Celsius, and again with a high pressure, about 200 atmosphere. So you have to remember the catalyst, you have to remember the temperature, you have to remember the pressure. So these three things are required, okay, by the syllabus for 0654, and the student need to remember them. Okay, so one of the very easy way, this is the only process, the whole chemistry for coordinated science, that you have pressure about 200. Okay, so this is a very unique, and you can remember because all of them are gassed, and if you know gas need to be compressed, then only you can store a lot of gas. Now, of course, there is also other reason. Some of you will learn in pure science, Le Chatelier principle, but I'm not discussing that now. So some of the hydrogen and nitrogen react to form ammonia. Okay, this process is reversible. Nitrogen will react with hydrogen to form ammonia, and at the same time, this ammonia will decompose back to form nitrogen and hydrogen. Okay, on cooling, the ammonia is liquefied and then removed. The remaining nitrogen and hydrogen are again recycled. So these are the three conditions that you need to memorize. So this is a very simple diagram. We have hydrogen and nitrogen. Hydrogen coming from the cracking of petroleum or steam. Nitrogen is coming from the fractional distillation of the air. Both of them are supplied into a reactor. This reactor contains iron powder to increase the surface area, and the temperature of this reactor is about 400 to 450 Celsius, and with the pressure of 200 atm, then it will form ammonia. And once it is transferred to this cooling reactor, the ammonia gas will condense to form ammonia liquid, and the ammonia liquid can be removed out. Whatever hydrogen and nitrogen that do not react, they will be recycled back to go through this process. So with this, all the 6 lessons, we have finished chapter 11. If you have any question, feel free to message me or write as a comment. I will answer to you. So that's all for today. Thank you and hope to see you again. Bye.